And we also discussed some defensive mechanisms that you could apply to protect yourself. And we'll extend that knowledge today. I will tell you about this keyword. Have we discussed this in the past? A firewall. What does it mean in plain English?
A wall of fire.
A wall of fire. I thought that as well, but actually it's something else. Imagine you have a house, and it has multiple rooms. For example, 3 rooms. And you have a fire here. It can spread, and then the whole house will burn down. However, if this is a firewall, it will prevent the fire from affecting the remaining part of the house. So the design feature, the purpose of a firewall is to prevent this transition from taking place. So it's not a wall of fire, but it's a wall that prevents fire from traversing it. And you could apply the same logic if this were a network and there are some bad people here and you have your infrastructure on this end, the firewall will prevent them from getting inside. That's the point, in very basic terms. My next question is, why do we need one at all? If I don't want anyone to connect to this machine, I'm just not going to open any ports, so they wouldn't be able to connect anyway. Would this work?
It's checking some connection.
Checking some connection?
Checking the connection and ask you if you want to give it access or something like this. Or for application. Sometimes when you open an application, the Windows asks, do you want to
allow this program to open ports and So you can have a firewall on the computer itself, which is a program that controls any network input-output operations that occur. You can also take it out of the user's hands. For example, imagine that this side is a bank. And this bank has a number of computers, and they all have data about accounts, about people's money, yours and mine. And all of them have application firewalls. And this thing doesn't exist. And you've instructed your people, the bank clerks who control these computers, to always press do not allow network access when the program asks any questions about this. Will this work? What do you think?
Maybe no.
Why not?
People can make mistakes and sometimes press oh, I don't know.
Okay, so people make mistakes, they are forgetful. Some of them are even very, very violent, aggressive manipulators who will purposefully turn off some security, perhaps because some person here will run an attack while the machine is unprotected and they are in some sort of relationship. They will split the money in half, for example. So even though you can have a software solution that you control from the computer itself, it is not always the best choice, because sometimes whoever controls the firewall may disable it either by accident or on purpose, and then your defense collapses. What do you do in this case?
hardware firewall?
Hardware firewall, that's very expensive.
Still,
Well,
we are a bank.
Yeah, we are a bank. I gotta take my words back. Is there something we can do on the computer itself before we do any investments in more hardware?
Well, we can connect all to another computer.
Mm-hmm.
A firewall, like a server.
So they don't have direct access to the internet. They can only access a specific machine, and that machine either allows or rejects certain actions. Mm-hmm. Okay. Now this suggestion of yours is about how you organize your infrastructure. Still, let's focus on the computer itself. Is there something you can do to prevent people from accidentally or purposefully disabling some security software?
Making new users that don't have access to disable or enable the firewall.
Uh-huh. So you can revoke permissions. Manipulating system settings, low-level settings, such as whether a firewall is on and which applications are allowed and not, is a process that requires elevated privileges. You have to be an admin to do that. Who runs their computers?
Unix stuff.
Huh?
Unix systems.
I didn't finish my question. So who uses their computers all the time as an administrator user or a root user on a Unix-like system?
The system administrator of the bank.
The system administrator of the bank. But does anyone in this room do that? Which is a very good thing, because if I asked the same question a couple of years ago in the same course, most people would say, I do this all the time. And my parents back at home do this. So everybody, when they set up a new computer, they just give it admin rights to the user. It usually just logs on automatically, doesn't ask for a password. And you give them great power and great responsibility, but they have no idea about it, so they just ruin it. So whoever runs those computers might configure them in such a way that users on the machines cannot change anything in its configuration settings. They cannot install or uninstall any new programs. So they will obey all the constraints that were already in place. But as you may have experimented in the past, there are different tools and ways and mechanisms that enable you to reset a user account password on a Windows machine, even if it's an administrative account, provided that you have full physical access to that computer. You can boot it from a floppy disk, from a CD, from a flash drive, and then run some special tools that reset the password to 12345, and then you log on and make your changes. So even if you revoke permissions, they can still do things that you don't want to happen. And in that case, you can do it the way he said, either by transferring everything through this little choke point that only you can access and manipulate and control. And this is where you could set up some rules, such as I can only accept connections from, and then specify some rules. So if you were a bank in Moldova, what kind of rules would you apply to your network security appliance?
Probably this server would be would have access only to the bank services, like online services. Is this one, it wouldn't be public.
Okay, so this is the internet. This is where all the people and the bad people are. This is the bank. The people inside the bank have to use some internal systems. And the people outside of the bank have to be able to log on and pay some bills, transfer money to a friend, or just check their balance. So what would be reasonable security settings for this thing?
I think there would be a dedicated computer, like a server for different outside services, like paying bills and stuff. And there would be a single computer that would be a gateway for the bank workers.
So all the bank workers will be connecting to some other internal computer.
And those computers could communicate somehow and perform transactions and stuff. So that we don't keep all the eggs in one.
Actually, this can be available because on those little computers that actually employees work, I don't think that there is certain information about all the customers.
You don't think that there is?
It's unreasonable. You need a separate server that will store this information and will serve this information.
Okay,
for
so
employees and for the other.
if I understand you correctly, you meant that there's not much of value here. All of it should be stored here.
Well, still they can access some services that allow performing some transactions that can move money from an account to another.
Yeah, from those machines.
Yeah, they have the controls. They may not store the data, but
They can manipulate it.
Yes.
So for example, if I set up a keylogger on one of these computers, I would be able to do some nasty things. Let's think about it in terms of ports. Should this appliance allow communication on any port from the entire range?
No.
He says no, but why does he say so? What do you think?
Because somebody can act from external. For example, we can configure another computer to access the bank account and send them some valuable information. And the server cannot always watch what someone do.
What do you think?
Maybe the probability for successful attack is much smaller when you use a specific port.
Okay, so let's say that all the bank customers on the internet only use it through a website. Which port number shall we allow for that purpose? 80?
Or 443.
Why this one? Okay, what is this one for?
Default port for HTTP.
This is the default HTTP port, and this one
Default HTTPS.
is for HTTPS. So as a result, you will only be able to connect or to establish a connection to this port, but anything else will be prohibited by default. And this is a good context to discuss whitelists and blacklists. Oh, gotcha. So there are 65 kiloports in general. And we only need these two. In a whitelist, we would say block everything except this and this. So this is 80 and this is 443. And if it were a blacklist, then we would have to do the opposite. We would have to say block port 1, block 2, block 3, block 4, and we would do this many, many, many times, and only for these two, we wouldn't establish such a rule. So what do you think is the key difference between whitelists and blacklists in terms of practicality? What do you think? You don't know? Of course, but if you think, you may extrapolate based on your past experience. Okay.
A blacklist assumes some bad stuff from the beginning, and the whitelist some good stuff.
Well, let me.
Are we talking about practicality?
Well, any kind of argument you have, go ahead.
For example, a whitelist may allow these two ports. What the whitelist basically says that don't ever block these two ports.
Yeah.
On the other hand, it may not necessarily specify that block all other ports. It can leave them in the default state.
I think we should define the terms.
Well, a whitelist, the logic is as follows. You blacklist everything except the items in the whitelist. So everything is blocked by default unless it's in the whitelist.
Well, it depends on the where is the black or white list, because there are softwares that use both the white list and the black list. And the white list contains the stuff that is never blocked. The black list is with the items that are always blocked. And the rest of them are in their default state, like they are allowed to be, they're neither they can work, but you can block them. You can add them either to the blacklist or to the whitelist.
I see. Well, that would be a lot of decision making then.
Really?
There is a new program, and every time it wants to do something, you will have to choose cancel or allow.
Like a firewall does.
Okay. Let's see if we can look at this problem from the perspective of another problem, that of antivirus and virus protection. So, if, let's say this is your computer and you have program A on it. This is what your bank clerk has to use on a daily basis. And this program is called a.exe. So this is the only thing they need, nothing else. And potentially, someone can send them a virus, which will be another program. Let's call it v.exe. The person can accidentally double-click it, and Windows will run it, and the computer gets infected, so that's bad. If you had a whitelist, you could say, I only have one trusted program, this one, which is white. Everything else, don't ever run it, don't ask any questions. If you did it the other way, let's see, you would have this, everything is black, except this little island here, which is your program. And the problem is that the number of programs in the universe is, well, it's not infinite, but it's a huge number. And every day you have new and new and new programs. So if you had to explicitly block every program, every day, you would have to keep growing your blacklist. And there is no bound to how many programs there ever will be created by humanity. So if you keep blacklisting everything, eventually you will run out of space on your blackboard. And of course, your blacklist will grow infinitely large. So it's much easier to manage a whitelist with a single entry than a blacklist with an ever-growing number of entries.
Anyways, it's up to the software that implements the whitelist or the blacklist.
In which way?
The firewall, the Windows firewall, for example, it doesn't have what you call the blacklist or a whitelist. When you try to connect, when your application tries to connect to the internet, the firewall asks you, like, do you want to allow this application to connect to the outside world? And you say allow. Then it's set it to the whitelist, and it means that you never get asked about it.
Okay, so
Another application, on the other hand, if it's not in a blacklist, it will keep you asking about the permissions.
so it depends on the policy of your
Yes.
security tool. It may be configured to ask everything and every time. It may be silently rejecting everything unless it's explicitly whitelisted, or the other way around. So we have now determined that we will block everything except these two ports. Will there be any other constraints that we can apply to further tighten security?
Constraints in terms of what?
Who can connect from the entire universe to the services provided by this infrastructure?
General.
For example, you can restrict by area. Like only IP addresses from this country or this region can connect. And if someone tries to connect from the outside, you can try to ask them for additional authorization. Like confirm your phone number or something like that.
But there are some extensions of Google Chrome, for example, that allow you to connect to any website. For example, some websites limit the connections so they permit a connection only from their country. I used this extension and it worked so well. I pretended to be an American user and it gave no problems.
Which extension do you use?
I forgot. I don't know the name, but it just lets you specify which country are you pretending to.
Is it a whole lot better internet?
I think it's Hola, something like this.
Or is it maybe...
Its icon looks like a fire, I think.
Well, you can use Tor.
Maybe it's uProxy?
No, it's not a proxy. I think it's Hola.
It's not found here. Well, there is a lot.
Well, there are indeed many of them, so I just added this keyword to the list. And then let's think about this one. Let's extend it. So his thought was that we can always inspect the headers of every incoming IP packet. We can have a look at the source IP address field. And we have to ensure that that source IP address belongs to the pool of addresses that are in Moldova. And if it's not, we just reject it without asking any other questions, because all of our customers are Moldovans. They never travel abroad. And let us just somehow simplify the problem and assume we only want to serve people who are here. And sometime in the past, I told you that there is an organization, IANA, that is responsible for allocating IP address ranges to different countries and companies. Therefore, there is some kind of a public registry where you can see which IP address ranges were allocated to internet service providers who do business in this country. So such a rule would be easy to implement, because all of the information you need is publicly available. And maybe if you remember, Some time ago, when the BitTorrent protocol just showed up, when it was something new, there was a new website. It was called torrents.md. That was before it was closed, and then it turned to torrentsmd.eu, etc. And it was also in the times when internet providers would not give you unlimited traffic for everything. You would have a very limited amount of gigabytes you could either upload or download on the internet. But if you were transferring something within Moldova, all of that traffic would be free of charge. So at that time, I think it was this. There were some people who would create a file, call it this way, and it would contain a syntax that would basically contain all the ranges of IP addresses that are known to be Moldovan, and you would give this file to your torrent client, and it would ensure that it only exchanges data with peers who are in this list.
Wait, so are you saying that at first torrents.md worked only for Moldovan users?
No, it worked for everybody, but the problem is that you would have to pay a lot if you exchange data with people outside of Moldova. Let me put it in other words. So your internet company gives you 5 gigabytes of upload and download. If you sum it, it has to be 5 gigabytes. But if it's inside Moldova, it's unlimited traffic. So you could, of course, exchange data with peers from New Zealand, but then you would quickly run out of your allocated quota of 5 gigabytes, and they would charge you a lot for all the extra. While if you were doing transfers only within the country, you would have unlimited traffic.
If someone opened uTorrent or whatever program he was using then, he may not even know that he is uploading, for example. After he downloaded it, it automatically starts uploading if someone else is downloading. So you may not even know that someone from abroad is trying to download this and you are giving him.
Yeah, and at the end of the month, when you see the bill, you realize that you should expand your knowledge further.
Yeah, fire this guy.
And fire this guy? Well, in this context, we're talking about household users like you and I. Anyway, so the point is that it is not impossible to have some sort of rule set that restricts your either inbound or outbound connections only to IP addresses that are associated with the specific country. You could do even something else. If you knew that all of your customers are clients of a specific internet provider, for example, let's say we had one that's called Acme. Then hypothetically, you could of course consult the data distributed by them. You could see which IP addresses were allocated to this company, and you could allow requests coming only from them, but not anyone else on the planet, and not anyone else in Moldova. So basically, you restrict the set of people who can connect to your server. And as you do that, you are less exposed to all the bad guys out there. You're only exposed to all the bad guys who have an account with this internet provider or who managed to take over a machine that happens to use this as their internet connection. Any questions about this? So there are software firewalls that run here. You could also have a physical appliance that is a separate computer, and that would be a hardware firewall. So now you have one criterion. Firewalls could be software-based or hardware-based. Now, another criteria is to which layer of the network stack does it operate? And we've touched this in the previous class. You could have one that filters only based on whatever it can find in the IP header, and whatever it can parse in the header of the transport layer protocol. For example, if you want to block by port number, you have to see what's inside the IP packet, because the notion of a port number only exists above the network layer. So you could be something that operates at the network and transport layer, or it could also be something that can look inside the payload of your UDP datagram or TCP segment, analyze that payload and make a decision based on that. For example, let's say that these people here are using quick chat internally to exchange messages. And somehow well, that's not going to work exactly as I described it hypothetically. Let's say that these people are exchanging messages in that program that you've played with in the past, and we want to make sure that they only use the public chat where everybody can read all the messages, and we want to prevent any person from sending private messages to each other. How are we going to do that?
Remove this function from the application.
But the program is already compiled. It's a binary file. You don't have the source code. You can't get the feature out of it. You can also ask people nicely, please don't send private messages. Or
does it connect to it should connect to a server. Okay, this application actually should have a server, okay? I mean, as far as I understand, and then the internal network should have all the list of IP addresses, and it may limit the connection between each other, but only to the server. It should allow only to server connection, not limit the connection between each other.
Well, you haven't used the program, right?
There's no big chat.
No, quick chat.
No.
But you're right in calling it weak chat because it's not very strong. But we use it as an exercise in the labs.
Okay.
But you have to see it before you judge it. But anyway, your point makes sense. But this program uses a different architecture in how it communicates. It's serverless. So you cannot have everything go to a server, filter it here, and then distribute it if you want it or not. Now, if you've analyzed the protocol, you would notice that it has a message that begins with some digit in the beginning. And this digit has different values depending on which feature of the program was used to invoke some function and send a network message. We've seen, or you've seen, that all the public messages begin with the digit, wow, So all the public messages begin with the digit 2, while all the private ones, do you remember? So it has a 6. So in this case, you would have to have some piece of software that is able to, if this is the network stack, somewhere here you have the network layer, the transport layer, and here you have the application layer. So it doesn't just have to intercept an IP packet here and look at its headers and decide whether I allow it or not. It has to actually open that packet. In the case of Quick Chat, inside the IP packet there will be a UDP datagram. So it opens the packet and it sees what is in its payload. Then it parses the header, it gets the payload out, and it parses that. So now it's at this layer. And using its knowledge of the protocol, the fact that in Quick Chat, the first digit, if it's 6, it's a private message, and if it's a 2, it's a public message. Using this knowledge, it can decide whether it will allow this message to go through or not. And that would be an application layer firewall. It's something that can look inside the payload of the application layer, use some knowledge of that protocol to decide whether it allows it or not. Such a firewall would be more complicated, more expensive. It would require more computing resources because while the IP header is fixed and so is the UDP or TCP header, you can have a lot of variation at the application layer, and there are thousands of protocols here. And you can't know them all unless you are a very sophisticated and expensive appliance of this type. Another problem is that if one day the author of Quick Chat makes any updates in the protocol, then you would also have to retrain your application layer firewall to be aware of the new version of that protocol and be able to analyze its messages to make decisions. Then at some point, one of you mentioned the word proxy. So who is using proxy servers besides him? So 1, 2, 3, 4, 5 people.
All our proxies the same.
I guess, yeah. I haven't used it, I just heard people talking about it. Let's examine a very simple example. A proxy that is for HTTP connections only. I'm going to recycle this drawing. So let's say this box here belongs to, it is connected to this internet service provider that everybody trusts in the bank. Acme. It's in Moldova, it's this provider, and this machine therefore can connect to the services provided by the bank. It also runs a special program here called a proxy server. And let's say this is the Atlantic Ocean, and somebody here in Brazil is connecting to this computer here, which runs a proxy server. The purpose of that server is as follows: to accept connections from a remote client and establish connections to another host on the behalf of this client. So it goes this way, and then it goes that way. Now this machine, it will open the header of the IP packet. It will look in the source IP address field, and in that field, it will find this machine's IP address. By following these constraints, it will decide that, yes, I will allow this connection because the IP address from which the connection request came is within our trusted environment. So it will accept the connection, it will then send back a response, and the proxy server will then take that response and forward it back to the person in Brazil. So this is what a proxy server does. You already know about one use case why a proxy server would be necessary, which is when you have a service, for example, a YouTube video that is only available if you are in the UK, but not available if you are in Moldova. And in that case, if you have a friend in London, you can ask them to set up a proxy server on their machine, give you the connection settings and configuration for it, so you can tell your browser not to connect to the service directly, but do this through a proxy server, an intermediary. What use cases would there be for a proxy server? Any other scenarios where it comes handy?
Fetching different data that is for free in limited amounts.
But you would use a list of proxy addresses.
Yes.
Yeah, it's a good idea to have multiple proxy servers.
Yeah, or hacking somebody.
Huh?
Or hacking somebody.
Hacking somebody? Yeah, because if you want to attack the bank, it's much better if they see this guy's address rather than your address. Because when they want to hit back, when they want to retaliate, they will point their guns to this machine rather than to this one.
The disadvantage of proxy is that there is technology, they can see that there is a proxy in between, and they actually can see the other guy from the first one. So the one who connects to the proxy server. Actually, especially the payment, while paying methods today, they actually see that users, when users use a proxy or a VPN or uses something like that.
All right. You've made some interesting statements. I added a keyword to this list. And then the next question is, how do they know you use a proxy?
That's what I would really appreciate if you could explain. Actually, I know that they actually do that, but I don't understand how it actually happens.
Well, I will tell you, but before I do, I want you to think about it and to generate some educated guesses based on what you know, what you've heard, what you've experimented with in the course.
Maybe by analyzing the packets.
So first of all, let's try to rule out some easy answers. I say that they use magic to determine that you use a proxy server. Do you think this is what they do?
No.
For someone, it's magic.
Okay, so I am going to write this and cross it off the list. So we've now made one step towards the right answer.
Maybe while connecting to a proxy, of course, you should use a port, and they would check if that at that port there is a proxy available for that IP address. So let's say the user and there is the proxy server, so they check the proxy server for an available proxy on that machine. So they would see if it's a proxy server, they would get it. But I'm not sure how they pass it to the other guy.
If you configure your proxy server not
To
to run on another port or not to accept
connections from banks.
Yes, okay.
So we have multiple ideas here. Go
I
ahead.
think it talks about public proxy servers or proxy servers that are known to everybody to use. They're blacklisted.
So let's say that there is some hypothetical organization, let's call it Proxytopia, which keeps a list of all the proxy servers in the universe. So whenever the bank has an incoming connection, it verifies if this connection comes from an IP address which is listed by Proxytopia. If it is, then obviously someone is using a proxy.
I didn't mean that.
You didn't mean that? Okay, then what did you mean?
I think there is like no way 100% to determine if it's a proxy server. You might use, for example, like TeamViewer for example. It's not a proxy, but you have the control of that. It will not be a proxy server.
Yeah, but we know, based on his feedback, that somehow they do this.
I didn't hear about that. I said maybe Philip knows about the list of known proxy servers that banks are blacklisting.
Okay, so they could do it this way.
How can there be such a company that knows about any proxy server? Isn't this thing available to be done on any computer?
Maybe he meant about the proxy list, which are paid proxies. Or
It could be paid proxies, or maybe you live in a country that has a very oppressive government that says, if you ever consider running a proxy, you got to get permission from me. And if I catch you doing this without my permission, heads are going to fly. And if you do that, then of course you will register with Proxytopia because you want to keep your head for a little longer.
To finish the point, I believe there is no way to determine this, as you said.
Let me extend our table here.
More like there is no way to determine 100% if it's a proxy or not. For example, if they are using proxies from these companies.
What about checking the time zone, the PC language, and so on? Because if, for example, I am from Moldova, my time zone will be different of that PC, initial PC.
Okay, hold on. I have to write things down. So here we have a list of things that won't work.
Okay.
In other words, if you try using any of these, the bank will still know that you are using a proxy. And in this list, we have entries that do work. If you do it this way, they will have no idea that you are
Using
a proxy. So you suggested that you could use TeamViewer.
like something like that. It's not like
Yeah, well, TeamViewer-like. You basically connect to it remotely and then run a browser here and do your thing. And this will work. Do you agree?
Yeah, it has to work.
Anything? It depends on what?
On the firewall.
No, actually, let's say the connection has been established, and that's it.
I think we discussed that device, that all the proxy server, or in our case, TeamViewers, have the permissions to access.
Yeah, because it belongs to this operator. It's in this country. It looks good. So what else can we do? You suggested that we use some clever extrapolation and guesswork by looking at time zones, languages.
Sure they do, actually. They also analyze the time zone of the PC, which actually requests some data, or which actually does some requests. They actually get the browser. They get, of course, they get all the initial data from that PC. The browser data, the language, the time zone, the operational system, and maybe, I don't know, some other data.
So basically they collect different metadata based on which they can do some guesswork.
Yes.
But does that guarantee you an exact answer?
No, banking is a really risky thing, so when they see something suspicious, they just decline it, and that's all.
Okay, I got it. But before you say anything, I have to ask another question. We live in Moldova. Who uses a Romanian version of Windows, Ubuntu, or whatever? Who uses a Russian version of any of those? One person. Who in their...
First of all, we are people from technology. I mean, actually, we are working on this area. But the people who are not working in this area actually do like their Windows to be in their own language.
But if we are talking about people using proxy servers, they are doing this purposely, and they would know that there is such a thing that checks for.
So they would probably change their settings accordingly.
Yes, they change their settings.
So, but I actually would think that it's really stupid to check those settings. So they actually won't change those settings while the banks will check them.
Well, it's very difficult to put yourself in the shoes of a person, especially if it's a stupid person. Anyway, let's hear you.
A proxy server may choose not to include headers like user agent or language into the request that is forwarded to the bank.
Exactly. In fact,
because they are not mandatory.
You know that when you send your HTTP request, it has a bunch of headers in it. They get here intact, but before sending them to the destination, it can change them any way it wants. It can add stuff, it can remove stuff, it can change stuff. So a lot of power is in the hands of the person who runs this. They can either leave your request as is, they can augment it by adding more stuff, they can remove the language, they can, let's say this person in Brazil, it says my language is Portuguese_Brazilian, but here it's rewritten as Romanian. So how would the bank still know that it's a proxy server?
What about the delay?
Delay?
Yeah, can they just anyway, while using a proxy, there is like a bigger delay while the browser or doing some stuff. It's really slow.
Well, it's not really slow. It depends, of course, on the weather and the temperature outside, but there is a lot of variation even within the country itself, so speed is not a good indicator. What else?
Proxy, it's a private proxy, it's a great probability that it's a fast proxy. Plus, when you look up the, well, you might lose a lot of time on looking up the DNS query. If you have an address, a domain name, you can lose time in looking it up. But when you use a proxy, you have an IP address, and already the proxy looks up the domain name of the client. So the communication between you and the proxy may be very fast.
Yeah, at the same time, for the bank servers, they won't notice that the request came to them that slow because they will think that the proxy server will actually do the request.
I think the most reasonable method to identify if it's a proxy or not is to use blacklists of public proxies.
Like Proxytopia.
Yes, or even buy lists of proxies for money from paid proxy servers.
Or you may even go as far as making your own underground network of proxies.
Yes.
And whenever anyone connects to it, you know who they are.
What about cache files?
Cache files?
Cache, no. Cache.
So what about them?
They're actually saved on that initial PC. They won't be saved on the proxy. On the proxy IP address.
Well, the cache file is used locally, so the browser here has a cache, and its purpose is not to ask for some image or resource if I already have it. It doesn't have anything to do with what happens on the server side, if I understand you correctly. Would there be a tool, a formal method of figuring out how is this request different from this one?
It may require a special application to be running, to be always running. For example, if I run an Opera browser, if that client doesn't use this browser, I can detect that
But nobody asks you to install anything. While you play, they just don't ask you to install something or open up something to check if you are actually
And also if you use Opera, like that client that is on the network and have access,
can change.
might not use Opera. It just sends the request, it doesn't send it.
not Opera, some special program.
Tell me.
The client may request some program.
The program that runs on device in between.
Yes.
Well, that program will make the request and give you the data.
No?
Nevertheless, this
You've got something to add.
Well, for example, one difference between the original computer and the proxy server is that the proxy server runs a proxy server, which listens on the port. There is a very little probability that the original computer also runs a server, their computer. For example, the proxy server might listen on the port 8000 or 8000. This port is open, so you can check if the computer that sent the request has
A listening port.
Yes, listens to some port. And you can elevate it as suspicious.
Okay, so let me summarize what you just told us. There are some ports that are typically used by proxy servers. Usually it's 8000. It's also 8080. You see it's a variation on this theme. So if I do this node here will check the source IP address. It will then try to connect to this IP at that port number and at that port number. And if the port is open, it will think, it has typical proxy ports that are open, so my guess is that it is perhaps a proxy port, proxy server.
The bank might even try to connect to itself through that proxy.
And see if it really works as a proxy. Yeah. And then it would know that it's definitely a proxy.
For those cases, some proxies use passwords.
Okay, but before you have to ask for that password, you still have to accept a connection at this port number.
But you can accept only one connection, as you said before in the beginning.
So you're right. If I am a clever person running a clever proxy server, I could configure it to only accept connections from Brazil.
Okay.
Or in fact, let's say that these people are brothers. I know his IP address and he knows mine. I only accept connections from here, and that's it.
And at the same time, we can run the proxy server on a different port so that one get the suspicious.
Exactly. I can run it on port 22, for example, so it looks like it's SSH, but it's something else. Or I can run it on port 1945 to commemorate the Great War, for example.
Well, you made all this proxy identification stuff is based on some heuristic that is the port number, because more than a half of the proxies will use those two ports.
Yeah.
So we can make a guess.
Perhaps there is another thing you could try.
What about using the network internet provider?
The network internet provider?
Yes. I mean, is there a possibility to use them? Actually, they also have the logs of all users, the connections, and so on. But this can be used after something was already done. But can this be used live?
Well, if they also happen to be the provider or the government or someone with a lot of power and leverage, perhaps they could.
It's connected to that proxy, and they will see there is an IP address connected, and they will actually find that person who actually connected to that.
Yes, but that requires a lot of authority, a lot of power, and it's probably going to be difficult to implement in a country such as ours, but much easier to implement in North Korea, Saudi Arabia, or
Russia, no.
modern day in Russia. I guess so. There's one more trick you could use. Let's say that there's this person in Brazil and a lot of other people from all over the world connecting through the same proxy. And this server here might do an analysis that goes like this. I have a connection from this IP address, which connected to my bank account number 5437. I have another connection from this IP address to another number, and there are thousands of them. So definitely, either this person is an oligarch in Moldova who has thousands of bank accounts in different banks, or there are thousands of people using it as a proxy server. So that could perhaps also be a clue that they use in order to figure out whether it's a proxy server connection or not. Something else?
But there is little probability that a lot of people would use the same proxy for the same bank in Moldova.
Yeah, the probability is not very great,
It is.
at least in theory.
At the same time, if those two guys are brothers, as you said, the probability that other guys will try to connect to this proxy server is not that much.
Yeah, because brotherhood is brotherhood.
Yeah.
As far as I know, there is a system which checks all the payments worldwide. They're just a service. And let's say I have an online shop, and let's say each of us has an online shop. And if we all use this server, then it can check much better.
Because it has data about all the merchants, not just about you.
So what they do, they only check for if this payment is actually good or not, if it can be accepted or not, and it connects all over the world. As far as I know, there are such services, and they are used the most. If you use the most popular one for your online shop, then most probably you want to get bad payments.
Does anyone run a website?
Yes, I guess so.
Well, could you raise your hand? Can you connect to it right now to see what's happening in its logs? Well, not in this second, but maybe during the break. So I suggest an experiment that you can try, and then you will see the answer. What's the difference between this and this? And the experiment is as follows. You run on this machine either TCP dump or Wireshark, and then you make a connection through a proxy and then make another one directly. In both cases, you will receive an incoming HTTP request, which will have a bunch of headers. I predict that, let's say this is scenario alpha and this is scenario beta. I predict that the headers in alpha will be different from the headers in beta, and I also predict that beta will add at least one header to its request by the time it reaches the server, and that header will contain the information you're looking for. Shall we run this experiment?
Shall we first do a smart proxy server?
Well,
As we have.
let's use whatever we can find on the internet. For example, Hola Better Internet, or any one of the ones available like this. So we use a public proxy, we connect to it, we send a request to this target machine, and we see what happens. Yeah?
How can we run Wireshark on the command line?
That's what you need TCP dump for. It's a tool that does the same thing. It either, using a set of filters, prints incoming stuff to std out, but you'll have a lot of output to look at, or it can store everything in a file in this format, pcap, and then you can take this file, open it in Wireshark, and see it in the GUI. So what I'm saying is that we can run an experiment that will be able to verify my hypothesis, which was alpha will be different from beta, and beta will contain at least one additional header. So now we can run the experiment, which will either confirm my hypothesis or it will reject it. If it's confirmed, it means I was right, and if it's not confirmed, I was wrong, and blah, blah, blah. But most importantly, you will find the answer to the question, how the hell do they know that I connected through a proxy server?
But I guess you, of course, have to be right. But
No, I've made a lot of mistakes in my life. Therefore, you have to run your own experiment. Don't trust me. Sometimes I could just give you fake input.
If we would use a paid proxy server, then it would be much better. Also, if we would use or if we would use a smart proxy server that we would monitor, that would be even much better.
But let's start with the very simple basic case. Is it time for a break?
Yes.
Okay, so